In this problem, we're given three tables of data. For each one, we're asked to determine if it represents a function that's linear or exponential, and then determine the actual equation for the function and type it into the cells. To remind you of the differences between linear and exponential, just look at this quick summary. If something's linear, we need to write the equation in the form y equals mx plus b, where b is what you get out when you plug in 0. The slope m, by definition, is the amount of change in y every time x goes up by 1. If the data is exponential, then we need to write the answer in the form y equals ab to the x. In exponential, a is defined to be the vertical intercept. It's what you get out when you plug in 0. And b is the amount of multiplicative change in y when x goes up by 1. So I'm going to do an example, a simple example of each of these before I get into the harder ones on Math AS. So I've made up a couple of really simple examples down here. The first one's linear. In my first example, it turns out to be linear because there's a constant additive change in y every time x goes up by 1. Notice that my x values are going up by 1s. 1, 2, 3. You can easily see that y is increasing by 2. 5 plus 2 is 7. 7 plus 2 is 9. If the numbers were more difficult, what you could do to find out that the pattern is to add 2 is you could do the opposite and subtract. 7 take away 5 is 2. Not that you need to do this, but this is exactly what I'm going to do in a minute when the problem's harder. So I'm going to just do a bunch of subtraction problems, 7 minus 5 to find the difference. And then if you find the difference between 9 and 7, you get 2. So that by definition is the slope. It's the amount of increase in y every time x goes up by 1. So my m is going to be 2. The b is what you get out when you plug in 0. You have to be a little bit of a detective here. I don't know what happens when you plug in 0, so I'm going to have to work backwards. If going to the right is adding 2, then going to the left would be subtracting 2. 9 take away 2 is 7. 7 take away 2 is 5. So if I was to back up a little bit to figure out what happens when you plug in x equals 0, I would have to just simply subtract 2. 5 take away 2 is 3. So I'm going to get a b value of 3. With exponential, it's almost the same thing except you're looking for a multiplicative pattern. Here it's clear that every time x goes up by 1, y gets multiplied by 2. So we say it has constant multiplicative change because you're always going to be multiplying by 2. 5 times 2 is 10. 10 times 2 is 20. So that automatically gives me the value of b. b is the growth factor, or I like to call it the multiplier. In this case, the multiplier is 2. Just like in the last example, we're going to have to work backwards to find the a value. A is what you get out when you plug in 0. So I need to extend the list here and figure out what I need to do to find what happens when you plug in 0. Well, if going to the right in the chart is multiplying by 2, every time x goes up by 1, y gets multiplied by 2. Then going to the left in the chart, if x decreases by 1, then the y values must be divided by 2. 20 divided by 2 is 10. 10 divided by 2 is 5. So this is going to be 5 divided by 2, or 5 halves, which you could write as 2.5. So when I see where I see a here, I'm just going to type in 2.5, and then I guess to pretty it up, you'd probably put parentheses, around the 2. So that's what it looks like for an easy example. If you want to go to Math AS now and see the more difficult version, it's maybe not as easy to subtract or divide in your head, but let me just see if this is linear or exponential. I'm going to try exponential first. What I'm going to do is I'm going to take 108.8 and I'm going to divide it by 136. And what that's going to do is it's going to tell me what the multiplier is between those two numbers. Meaning if I took 136 and I multiplied by 0.8, I'd get 108.8. So I'm wondering if that is constant. Remember, for it to be exponential, the multiplier has to be constant. So I'm going to keep doing this. I'm going to take 87.04 and I'm going to divide it by 108.8. And again, I get the ratio is 0.8. Finally, in the last iteration, I have 69.632. I'm going to divide it by 87.04. And the reason I'm doing this is it's not obvious to me what you multiply 87 by to get to 69. So by dividing in this order, in this particular order, I'm uncovering what the multiplier is. It looks like the pattern is to start with 136 and multiply by 0.8 over and over and over again. In fact, if you wanted, I could take 136, multiply by 0.8, and you'll see that I get 108.8. If I multiply that by 0.8, you'd see that I get to the next number, 87.04, and then if I multiplied by 0.8 again, finally I get to 69.632. So this is definitely exponential. There's a constant multiplier, and that would be the value of b. So now I know that b is 0.8, but if I'm going to write the equation, I also have to know what a is. A is what you get out when you plug in zeros, so I'm going to have to work backwards. So if going to the right in the chart is multiplied by 0.8, going to the left would be dividing by 0.8. So I'm going to take 136 and divide by 0.8 to figure out what would happen if we plugged in 0. So if I had room to write in here, going backwards, the x pattern going backwards would be 4, 3, 2, 1, 0, and that's what I want. I want to know what happens when you plug in 0. And then going backwards with the y values, you divide by 0.8 over and over again. And here, if you take 136 divided by 0.8, you get 170. So this one is exponential. Its equation would be the a value is 170, that's the start value. In parentheses, we write the multiplier, or the growth factor, that's 0.8. Some faculty call this the decay factor because it's actually going to indicate decay. I like to just call it negative growth, either way. And then I'm going to have to use the caret key and then type in the variable x. If you want to make sure you typed it in right, you can hit preview, and that looks like a good exponential equation. The next one, just to save time on the video, turns out that it's linear. So for example, if you divided negative 31 over negative 111 and 49 divided by negative 31 and 129 divided by 49, you'd get three different numbers. They wouldn't be the same, so they would not have constant multiplicative change and therefore would not be exponential. So this one turns out to be linear. I think it has constant additive change. To figure out what somebody added, if you're not good at arithmetic, what do you add to negative 111 to get to negative 31? What you can do is the opposite, and you subtract, just like we did up here with division. You take the one on the right and you subtract the one on the left. Because I'm trying to uncover an additive pattern, I'm going to subtract. Up here we were trying to find the multiplicative pattern, so we divided. So what I'm going to do is take negative 31, I'm going to subtract negative 111. That gives me 80. Now understand what this means. That means that to get from this number right here to that number, I could add 80. The question is, does that the pattern continue? If I added 80 to this number, would I get to 49? And would I add 80 to 49, would I get to 129? The answer is yes, but I'm going to actually just do the differences just to show you. 49, take away a negative 31, turns out to be 80 as well. And finally 129, subtract 49, gives me 80 as well. So what this means is I could start with negative 111 and repeatedly add 80 to get from one y value to the next every time x goes up by 1. So my m in y equals mx plus b is 80. That's my slope. So I'm going to write, select answer here. I'm going to pick linear. I'm looking for something in the form y equals mx plus b. We just uncovered that m is 80. So it's going to be 80x. Now I have to figure out what my b is. Well, again, we're going to have to be a detective and work backwards. The x values going backwards go 4, 3, 2, 1. If I went backwards, the next one would be 0, and that's the one we're after. We're looking for what happens to the output when the input is 0. So we'd likewise have to go backwards in the chart with the y values. Since the pattern is to add 80 to the right, the pattern would be subtract 80 when you go to the left. 129 take away 80 would be 49. 49 take away 80 would be this one. This number take away 80 would be this one. Finally, we would take negative 111 and we'd subtract 80, and that would give us the output when the input is 0. So that's my vertical intercept, negative 191. So I'm going to go here and I'm going to type in subtract 191. By the way, had the pattern not been a constant additive amount or a constant multiplicative amount, then the answer would be neither. Now, I didn't ask that in this question, but in a different problem on Math AS, they asked that, and I intend on actually uploading that video to that question as well.